Hello and welcome to my restoration of an Allen Scythe. This is an Allen Scythe dating back to the early 1950s, but the John Allen of Oxford & Sons company was actually manufacturing them from 1933 to 1973, meaning some of the earlier machines were actually used during the Second World War. This model is fitted with the Mark 15 4-stroke Villiers engine, which is actually quite unusual. The 2-stroke version is much more common. As you would expect, the Scythe's principal role is to cut down long grass or brush using the reciprocating cutter blade. However, later in production, a plethora of attachments were available for it, including a circular saw, generator, and even a chainsaw. So let's start the restoration, and because I don't know the history of this machine, I need to make a few checks first of all. This includes checking the oil, checking inside the bore, and also checking the fuel. Yep, I can definitely see oil in there. Well, that's not a great sign. The spark plug does look quite rusty, which obviously means there is moisture on the inside of the bore. Let's take a closer look with the bore scope. Okay, I'm seeing a lot of sludge and, well, it looks a bit more like a rock pool than the inside of a cylinder bore. That's not good. I've already seen enough. Let's remove the engine and get it into the workshop. At least the inside of the gearbox looks clean and rust-free. Before even starting the disassembly of the engine, it's already clear to see how the water actually got into the cylinder bore. Because there is no muffler or silencer on this engine, it's just gone straight down the exhaust manifold, through the exhaust valve, and straight into the bore. These old engines were started with just a simple rope, rather than the recoil systems that we see on modern engines today. Removing the exhaust manifold gives us an insight of what to expect as we delve deeper into the engine. Next, the cylinder head nuts, the rocker cover and the intake manifold are removed, so I can then remove the head. It's time to reveal the horror that lies within. Yeah, as I was expecting. And of course this rust has come from the important components such as the cylinder bore, the valves, and the head. I'm now going to drain the lake and see exactly what lies beneath it. The excavation has begun. After leaving some lubricating oil just to soak in, I have managed to free the piston, so it does now move. However, it is certainly revealing the extent of the damage, and it does not look good. I now have a big decision to make. I could have the engine rebored and then I could fit oversized rings. However, I've looked into the rings and I can't actually find any oversized ones at all, only standard ones. Also, reboring it might not help at all due to the depth of the corrosion. Despite the rarity of the 4-stroke engines, I'm going to put this one to one side and attempt to source another one. In the meantime, I'm going to continue with the restoration of the rest of the Scythe. The first step is to remove the jib key which holds the wheel on. To assist with this, I'm actually using a bit of heat, and a jib key removal tool which is also used on machines like combine harvesters. The easy turn ratchet drive can now be removed, and this is fitted to the scythe to enable the drive to be locked for safety when working on steep slopes. I suspect it's been quite a few years since these ratchet gears were removed, so a 3-leg puller really does come in handy to assist with the removal. With a bit of persuasion, the wheel then slides off the shaft. On the right hand side of the scythe we do have the clutch setup, which needs to be disassembled so I can then remove the handlebars. With everything else removed, we are just left with the ratchet gear. Thankfully no components have been too stuck, although I don't want to speak too soon. The disassembly process can be repeated on the left hand side, although this side does not have any of the clutch mechanism. Now the fun really begins. It's time to remove the gear case cover. Wow, they don't make them like they used to. Yes, that worm wheel is made from solid phosphor bronze. I always love to see the high quality workmanship that goes into these old machines. They just really do not compare to machinery that you can buy today. And on the underside of the top cover we have the balance weight for the reciprocating rocker. Before we go any further with the disassembly, I need to remove the oil from the gear case. The first component to remove is the axle with the worm gear. This is then followed by the crank die, which essentially connects the whole of the drive system to the reciprocating part of the machine. We then have the bridle, which basically is what engages and disengages the drive. On the very end of the cutter crank we have a castle nut and a slip clutch spring. With this removed I can then continue the disassembly of the cutter crank. The worm gear, some spacers, the cutter crank and the slip clutch can then be removed from the gear case. Now is a really good time to give this thing a bit of a clean. It really stinks of old gear oil. As I'm going to be sending all of these components off for sandblasting, I'm trying to make them as clean as possible, so I'm using some solvent to really get all of that horrible old oil out of there. As I don't really want the rocker fulcrum and the weight to go off for sandblasting, I'm removing these from the top of the gear case. I must say at this point I'm very impressed with all of the components. I've not actually seen any wear and tear, and I think really it's just the engine which is wrong with this machine. But it did all need to be disassembled anyway, so it can be painted properly. All that's left to do is to remove the two pulls for the ratchet system and the tyres from the rims, and then everything can be sandblasted. And there we have it, the whole of the side has been disassembled and all the large components can now go off for sandblasting. As you can see, I've covered over the inside of the gear case just to try and keep the majority of the sandblasting media out of there. Also to be added to the pile, we do have the engine cowling, but it does have two plates on it which need to be removed and preserved. First of all, we have the machine ID number and also the Villiers ID and instructions plaque. The engine cowling is ready as well, and I really hope I can find an engine for this because after all, it is a superb machine. And Allen of Oxford's slogan was "Wherever a man can walk, an Allen will cut," which is an incredible statement to make. But to me, that statement really is true, because as you've seen for yourself, the quality of engineering which is put into every machine that they made is outstanding. And I was actually lucky enough to get hold of one of their brochures from 1964, which is absolutely filled with different photographs from inside their factory. In this photo you can see a lathe boring for the axle bushes. In the machine shop for the Model TS, which is the scythe that I'm restoring, you can see all of the gear cases stacked up, and that really does represent how many machines they were making. Unlike many companies today, there was no mass production. Every single machine had individual skill and craftsmanship put into it, with rigorous inspections. Here we have 4 gear wheels being cut simultaneously. If you're unsure of which component this is, I've labelled it on my side. Here you can see the cutting of the phosphor bronze worm wheel. And this is the machining of the worm drive. Precision of this part is vital as it must mate perfectly with the gear. Sadly, after production ended and the company ceased trading, the factory was demolished and is now called the Templar Retail Park, although it is also known as the John Allen Centre, which I thought was nice because although the factory has gone, it's not been forgotten. If you visit this complex in Cowley, Oxford, then take a moment to appreciate the incredible manufacturing processes that occurred on this site over 40 years ago. It took a while to find a replacement engine, but I've done it. I was starting to think this project would never be finished. This engine also is untested, so there is a chance that it's going to be as bad as the previous engine. It has oil in it, which is a good sign, and the only other test I've done is to pull it over by hand, and it doesn't seem to have any compression at all. So let's discover if this engine is going to be good enough for us to be able to complete the project. Clearly, the engine oil is very clean, almost too clean. What I need to do is remove all of the components so that I can access the cylinder head and remove it if necessary. This rust looks ominous. With the engine cowling removed, it's clear to see that there is a bit of damage to the flywheel. 3 of the cooling fins have been broken off, and also there is some fairly excessive orange rust inside the cover itself. So I'll probably be using the cover off the first engine if this engine turns out to be good. I've also taken a look inside the cylinder bore with an inspection camera, and it looks like it's full of rust, but luckily this time not water. So I'm going to go straight ahead and remove the cylinder head so that I can clean it out in there before I go any further. The rust inside here definitely looks like coffee grounds. Luckily it's nice and dry so I can very easily clean this out. You may have already noticed, but the piston does not have any carbon on it at all, neither does the cylinder head or the valves. This is very interesting because it likely means that somebody has already dismantled the engine, or at least the top half, and then put it back together again but never run it. It leaves the question, why not? Maybe they couldn't get compression. So I'm going to conduct a leak down test to find out where the problems lie. As you can see from the cylinder leak down test, it has failed spectacularly. So where is it actually leaking from? The intake valve? The exhaust valve? The rings? Well, yes, it looks like it is the intake and the exhaust valve because there is significant air leaking out of both the exhaust port and the intake port. With a bit of luck, the valves just need to be relapped so they can create a good seal. I'm now going to dismantle the entire engine, get it cleaned up, painted, and then reassembled. The rust on this drive gear clearly gives away that it's not been fitted to a scythe for many years, because that will usually sit inside the gear case, where it's bathed in oil. Oh yeah, and it's on a taper, so it goes with a bit of a bang. Underneath the flywheel we have the ignition system, which is also where the points and condenser are, and these will need to be set up properly when the engine is reassembled. It does look quite clean in here, but that's probably because of the fresh oil. There is still a bit of sludge in the bottom of the sump, but nothing unexpected. The first component to be removed is the governor gear. This is followed by the connecting rod and piston. Note the oil dipper, which is integrated into the casting of the big end. The dipper splashes oil and lubricates all the components when the engine is running. When the engine is reassembled, these 2 timing dots will have to be aligned on the crankshaft and the camshaft. Unlike modern engines, the camshaft is actually on its own shaft which needs to be pressed out of the crankcase. Once that has been removed, the camshaft simply slides out. The final few components are removed. This includes the governor shaft, the valve tappets, and the bearings. The bearings will be replaced with new ones. That is the main part of the engine disassembled. Next, the cylinder head also needs to be disassembled, and then after that, all the components can be cleaned thoroughly. The disassembly of the head involves removing the valves and the rocker. After a quick inspection, it doesn't look like the valves have been lapped in recently. Also, the valve seats are looking incredibly rusty. So I'll address this issue when I rebuild the head. I'm using a hot degreaser washer to remove all of the grime and oil from the components. I'm using the sandblaster to remove all of the rust and to clean up the head. I'm going to hone the bore because clearly it does not look good. Also, by honing it, it should allow the piston rings to seat. After honing a bore, it is imperative to clean it thoroughly. I actually did this off camera, but I did clean it with soapy water and then with brake cleaner. To prevent all of the components from rusting, I'm giving them a good coat of etch primer. I won't actually do the top coat though until the engine is fully reassembled. I've inspected all of the parts and I'm incredibly happy with most of them, so I can now start the reassembly. When reassembling engines, I like to use the Permatex reassembly oil. Now the piston rings do look brand new, and they probably are because I think somebody has actually rebuilt the engine, it's just they never succeeded with getting it running. So I'm just going to give them a good clean and also check the ring gaps and hopefully reuse them. After checking all the rings, they were all within spec and I can now refit them to the piston. Although I did manage to find a gasket set for this engine, I couldn't find a sump gasket, which is strange, so I'm having to make my own here, but it's not a problem because it's not really too tricky. All you need is some gasket paper and a hammer. With the gasket made, I'm applying some Permatex high-tack sealant, and then the sump can be fitted to the crankcase. Now to rectify the issue which was most likely the reason why the previous owner never got it running. I'm simply using some fine lapping compound, and it basically just grinds the valve into its seat, and this creates an airtight seal. Without a good seal, the engine can't create compression, and without compression, it can't complete its combustion cycle. You can see that nice silver ring on the valve face. With both the valves lapped in, the cylinder head is then cleaned thoroughly. I'm using some brake cleaner, and it's then reassembled. The two push rods are fitted, and these basically sit into the valve tappets. As the camshaft rotates, the valve tappets push up on the push rods, and that in turn moves the rocker, which will then open and close the valves. As mentioned, I do have a gasket set, so I'm fitting a brand new head gasket. From this point onwards, it is just a reverse procedure of the disassembly. With all the work done to the engine, let's conduct another leak down test to see if I have resolved the issue. Brilliant. Less than 20% leakage, which is in the green and is a very good result. All that's left to do is to set the valve clearances. I'm applying a nice coat of lacquer to the rocker cover just so we can keep the aluminium look without running the risk of it oxidizing. The final few steps of the engine rebuild can continue. I fitted new seals and bearings into this plate. As I definitely don't want to paint any of the ignition system, now is a great time to give the engine its top coat. A few days have passed and the paint has now cured, so I can continue with the rebuild. I'm now fitting the ignition system, and this does need to be done in a certain way. Basically, the points need to start opening when the piston is just coming up to top dead centre, about 1/8 of an inch from the top. Although it's very difficult to see on camera, everything is timed and the flywheel can be fitted. I've painted and fitted the engine cowling, and with that in place I can now fit the engine kill switch. There's only a few parts that need to be restored before the engine is finished. Firstly, we have the engine pull start cup, which is fitted with 3 Allen screws. And then we have a particularly vital component, the carburettor. I'm actually using the carburettor off the first engine which I got, because the second engine's carburettor does not look very good at all. So let's take a look at this one. There is some rust in there, that is really to be expected, especially when you consider what it looked like inside the engine, but it's really not too bad. So I'm going to get this all cleaned up, and hopefully it's going to be perfectly usable. Luckily I do have a replacement bowl gasket as well. Firstly, I'm giving the whole carburettor a preliminary clean with some carb spray. After that, it's going into the ultrasonic cleaner. In case anybody's wondering, this is just simply hot water mixed with a bit of washing up liquid or dish soap. After around half an hour of cooking in the ultrasonic cleaner, the carburetor is looking much cleaner. The next step is to dry off the parts with some compressed air. After another quick spray with some cleaner, the carburetor is now ready to reassemble. To clean up the rust inside the bowl, I'm using a sandblaster. As you can see, that's made a big difference, but for obvious reasons I did not want to blast it too aggressively. With the carburetor clean and rebuild finished, it can now be fitted to the engine. As I've done with all the other rusty components, I've sandblasted the exhaust manifold. As exhaust manifolds have a tendency to get quite hot, I've actually painted this one in stove paint, so very high temperature. And this is actually as far as the engine rebuild can go for the time being, because I can't go any further until the scythe is ready. All of the major components have now returned from sandblasting, and I'm giving them a good application of primer. I always try to get the sandblasted components primed as quickly as possible because they can very easily flash rust, and if they were to get wet, well, they'd probably need to be sandblasted again. With the primer cured, it's now time for the fun part, the top coat. And of course, it's being painted in Allen Scythe green. It is surprising how long it takes to do several coats on all of these different parts, but they're now done. So let's reassemble the scythe. First things first, I need to fit the two new bearings into the gear case. They are a very snug fit and access isn't great. With the second bearing, I actually put it into the freezer to try and shrink it a bit, and that did make fitting it a little bit easier. I also put the cutter crank in the freezer in an attempt to make that easier to fit too. So far so good, the components are going together nicely. As you would expect, it is just the exact reverse procedure of the disassembly. So, in theory, very simple. I'm cleaning the machined gasket surfaces with some brake cleaner, as I'm going to be applying some sealant to these. This is more to keep water and dirt out, because the oiling system is basically an oil bath at the bottom, rather than it being filled up to the very top. The gear case reassembly is complete. Now it's time to take it outside where there's a bit more space and I can fit the handlebars, and I can also fit the external clutch components. It's now time to fit the tyres, and sadly, you can no longer get the original ones. However, I did manage to source some which do fit, they just don't feature the exact same tread pattern. There is something so satisfying about fitting new tyres to a rim. To really finish the rims off nicely, I'm using a gold paint pen to make the writing stand out. we're getting there. All that's left to do now is a few finishing touches to the engine, and then that can be fitted, and then finally the cutter bar, which we'll come on to in just a minute. I actually have two cutter bars, and I'm going to restore the one which is already in better condition because the other one is quite worn and the blades are very damaged. Firstly, the cutter bar is dismantled, so all the parts can be cleaned up separately, and then I can prime them and paint them with a nice top coat. I am going to stick with the bi-colour scheme, so green for the main bar and then red for the knife. To sharpen the knife, I'm simply using a hand file. With the blade sharpened and painted, it's then fitted back onto the cutter bar, and I'm now fitting it to the machine. And now for the moment I've been waiting for, fitting the engine back onto the Scythe. It's been a few years since it was removed and I never thought the day would come. A new throttle cable is threaded through the handlebar and into the throttle lever. It's also attached to the carburettor on the other end. Thankfully, the replacement engine which I managed to get hold of had a really decent silencer, so I've just sandblasted this, primed it, and I'm now painting it with the high temperature stove paint. There is one last hurdle that we need to get over before we can test the engine, and that is the fuel tank. Now initially I thought this was in quite good condition, but after a closer inspection it does have a few perforations. So what I'm doing here is removing the paint, then I'll roughen up the surface with the sandblaster. I can then weld up the holes and then powder coat it in red. After 15 minutes in the powder coating oven, the fuel tank looks brand new. With the fuel tank attached, there's only a few more jobs left to do, such as connecting the fuel line and putting oil into the gear case and the engine. But I do also have a small fabrication job coming up as well. Before I get onto that though, I'm just putting the gear oil in, and basically the way you do this is you remove the side drain plug and you fill it up to that level, and then you can put the two plugs back in again and you know you have the correct amount of oil. The engine takes Castrol XL oil. I put a pint in and then use a dipstick to get the correct amount. Oh look, all of this year's ducklings have come to say hello, although they're getting big now. They're getting old enough to show an interest in Allen Scythes. As with all my restorations, in goes a brand new spark plug. So about that bit of fabricating I mentioned, I just need to make a quick guard for the pull start cup on the flywheel. As I don't have a metal bender which can fold this thickness of metal, I'm just going to heat it up and then use the vise. With the metal bent into the desired shape, a hole is drilled so it can be clipped onto the engine cover, and also a small piece of tube is welded to the bottom so it can actually be bolted on. A quick coat of primer and then top coat just to make it look good, and then it's ready to fit. To give the side a more original look, I've also created a few decals. Remember this engine plaque? Well, I'm just giving it a good clean. I'm actually using a bit of Brasso for this, and it's worked well. It does bring it back quite nicely. As for the other plate, well, sadly the writing is very worn, so I've decided to remake it. After remaking it and having it printed professionally, here it is, and I'm quite impressed by it. I could even rivet this on as well if I want to, but for the time being I'm choosing the self-adhesive backing. And approximately 3 years after starting the project, it's finished. There we have it, the Allen Scythe. It has been a great journey with this machine. At times I didn't think it was actually going to be finished. After finding a suitable engine, it was made possible once again. So let's see it in action. The Allen Scythe, manufactured between the 1930s and the 1970s. It's certainly a heavy machine, but also very, very well built, and it was a great experience giving it a go. Thank you so much for watching, everybody. If you have enjoyed this video, then please do remember to like and also subscribe. These videos just cannot keep going without your support. Until the next restoration, see you again soon. Bye for now.